How do we build AI we can actually understand? And maybe more importantly, how do we build AI we can trust? In this explainer, we're going to dive into a really powerful approach that might just be the answer: axiomatic fuzzy modeling.
You know, this is one of the biggest questions in technology today. We have these incredibly powerful AI systems, but when they make a decision, they often can't tell us why. This is what everyone calls the black box problem.
And that's a huge issue. I mean, think about it. Whether it's in medicine, finance, or even self-driving cars, if an AI can't explain its reasoning, you've got some serious problems with trust, with safety, with accountability. We have to be able to peek inside that box.
So where do we even begin to solve this? Well, it all starts with a pretty fundamental shift in thinking. We have to move beyond that rigid black and white computer logic and start to embrace the beautiful ambiguity of the real world. This slide just breaks it down perfectly. On one side, you have traditional binary logic. It asks, is it hot? The answer is a simple yes or no. But fuzzy logic? It asks, well, how hot is it? And suddenly you can have answers like cool, or warm, or really hot. It's literally the difference between an on-off switch and a dimmer switch. It allows for degrees of truth.
So what we're talking about here is something called many-valued logic, and it's built from the ground up to handle all that real-world messiness and imprecision. I mean, just think about how we talk every day. We use subjective terms all the time, and fuzzy logic finally gives AI a way to get a handle on that.
Okay, so it makes sense, right? If we want an AI to think a little more like a human, we've got to teach it to speak our language. We need to build a kind of interpreter, something that can act as a bridge between how we think and how machines actually process information. And that leads us to this absolutely brilliant idea from Lotfi called the linguistic variable. So instead of a variable for temperature, having to be some super precise number like 72.3 degrees, it can have values that are just words. Words like cold, warm, or hot. This lets us feed information to the AI using our own natural human terms.
And here's where the magic really happens. Look at how this works. First, you define a variable, let's say speed. Then you give it those human-friendly terms like slow, average, or fast. And just like that, the AI can suddenly understand these incredibly intuitive rules, like if the speed is fast, then apply the brakes hard. That's a rule we can all understand instantly, which makes the AI's logic so much more plausible to us.
Okay, but hold on. Just teaching the AI the words isn't the whole story, is it? To really trust it, we need to make sure it's using that language consistently, logically. It's like the interpreter can't just make stuff up. It needs a strict grammar book to follow.
And that is where the axiomatic part of the name comes into play. You see, an axiom is just a foundational rule, an established truth. So instead of just relying on educated guesses or assumptions, axiomatic modeling lays down a formal mathematical set of rules for what interpretability even means.
So these axioms are doing a few really important jobs. They're making sure the AI's reasoning is always consistent, always justifiable, and on a much deeper level, they create this incredible framework that can handle two totally different kinds of uncertainty at the same time: the fuzziness of our language and the cold, hard randomness and probability of the real world.
All right, so let's put all the pieces together. Let's see how this all comes together to create AI models that aren't just easy to understand, but are also seriously effective.
For the longest time in AI, there's been this big trade-off. You could have a model that was incredibly accurate, like a deep neural network, but it was also a total black box. Or you could have a simple model you could understand, but it wasn't as powerful. Getting both? That was the real challenge. And this table just lays it out so clearly. Look at the typical black box AI: low transparency, conditional trust. Now compare that to what axiomatic fuzzy modeling is aiming for. Instead of these ridiculously complex, hidden rules, it builds models from simple combinations of those linguistic terms we talked about, rules we can actually read and make sense of. It's all about finding that sweet spot: high accuracy, high transparency, and as a result, a high degree of justifiable trust. And hey, don't think this is just some theory locked away in a lab. This approach is being used right now in really critical fields where clear reasoning is an absolute must. Think about recommender systems. Instead of some mystery algorithm, imagine a system that can understand a request like, I want a movie that's kind of funny, but not a full-on comedy. That's the kind of nuance this makes possible.
So yeah, when you boil it all down, it really comes back to these two pillars. The whole game, the whole payoff, is achieving that crucial and often really elusive balance between a model's raw performance and our ability to actually understand and trust what it's telling us.
Which kind of leaves us with this big final thought. Building trust in our technology isn't just a coding problem, it's a deeply human one. As we build AI that can finally explain its own reasoning, we're not just improving a system, we're opening up a whole new kind of dialogue with our own creations. And that might be one of the most important challenges of our time.